Good day, I'm Maile Matsiba. Welcome back to our channel. Today we continue with our section 2 of the 2017 study guide. We're going to be looking at example 2.7.3. It says a solution of methanol, ethanol and water has the following analysis: ethanol 30%, methanol 45% and water 25%. What is the analysis on a mole basis? Now, because the question says what is the analysis on a mole basis, it's important that our first step be calculating the number of moles of each compound. So I'm going to write that step 1, calculate the number of moles of each compound. Now, that is actually our step 1. We're going to be calculating the number of moles of each compound. Now, with that said, simply because our analysis is actually in percentages, it's important that we have a basis. We choose a basis. And the basis we're going to be using is going to be 100 kilograms of the solution. That means our solution in total is actually 100 kilograms. Therefore, that means that if our total solution is actually 100 kilograms, that means our ethanol, the mass of ethanol is equals to 30 kilograms and the mass of methanol equals to 45 kilograms and the mass of water equals to 25 kilograms. Now we have the masses of each of the compound on a 100 kilogram basis, and the question, remember, says calculate the number of moles. Now we continue further to say, let me just say the number of moles of ethanol equals to the mass of ethanol all over the mole mass of ethanol. Now equals to the mass of ethanol is actually 30 kilograms over the mole mass of ethanol. It's actually 46 kilograms per kilomole. Let me just write here that mole mass ethanol equals to 46 kilograms per kilomole. I think it's clearly visible. Now, when you do your calculation here, you get 0.65217 kilomole. That is our ethanol. That means in a 100 kilogram solution, there's actually 0.65217 kilomole of ethanol. So now the number of moles of methanol is equal to the mass of methanol all over the mole mass. The mole mass, I hope it's visible, the mole mass of methanol. Now, the mass of methanol, we know it to be 45 kilograms, and the mole mass of methanol is 32 kilograms per kilomole. Let me just write here mole mass methanol equals to 32 kilograms per kilomole. Now when you do your calculation there, you get that you have 1.40625 kilomole of methanol. Continuing further with the water, the number of moles of water equals to the mass of water all over the mole mass of water. Now the mass of water, we calculated it to be 25 kilograms, and the mole mass of water is 18 kilograms per kilomole. Again, I just want to highlight here, mole mass of water is equals to 18 kilograms per kilomole. Now if you use a calculator there, you get 1.38889 kilomole water. Now that we have all our kilomoles, or the number of each, the kilomole of each compound, we say total moles of solution equals to 0.65217 kilomole plus, well, that is the kilomole of the ethanol, plus 1.40625 kilomole, that is our methanol, and then plus 1.38889 kilomole, that is the water, and the total becomes 3.44731 kilomole. So we know that our total number of kilomole is 3.44731 kilomole. Now with that said, we now have the total number of moles of each compound in the solution. This is going to take us to our second step. In our step 2, remember the question says that calculate the number of, they say what is the analysis on a mole basis. So which means that we're going to be, in our step 2, now that we have all the information on moles that we need, our step 2, we're going to calculate mole percent of each compound. So in our, sorry, let me just write it here so it becomes clearly visible. So our step 2, in our step 2, we're going to be calculating the number of the mole percent of each compound in the solution. Let me just write here that in the solution. Now, with that said, if we're going to calculate the number, if we calculate the moles of ethanol, we're going to be calculating the mole percent. Mole percent ethanol is equals to the mole of ethanol all over the total moles. That becomes, our ethanol was 0.65217 kilomole all over. Our total number of moles is 3.44731 kilomole. Oh, sorry, I forgot to put the 100% here. Remember, we're calculating the mole percentage, so it's actually the mole. This is actually the mole fraction multiplied by 100%. So yeah, now if you use a calculator here, you get 18.92% ethanol. Now our second one is mole percent. It's mole percent methanol. It's equals to the number of moles is moles methanol all over total moles multiplied by 100%. That becomes the moles of methanol. We found it to be 1.40625 kilomole all over. Total mole is 3.44731 kilomole multiplied by 100%. Now when you use your calculator, you find that the methanol is actually 40.79. The methanol is 40.79%, or let me just say 40.79% methanol. Continuing further, we say the moles of water equals to the mass of the water all over, sorry, not the mass, the moles of water all over, the total moles multiplied by 100%. That becomes the moles of water. We calculated it to be 1.38889 kilomole all over total mole, which is 3.44731 kilomole multiplied by 100%. Now if you use your calculator, you get water to be 40.29%. Let me just say 40.29% water. So now this is actually our analysis. So let me just say mole analysis, just rewrite it, it's equals to 18.92% ethanol, 40.79% methanol, and 0.29% water. So yeah, that is our analysis. Thank you for your time, and I hope to meet again in our second video.